Welcome to today's lesson. Today we are on Unit 2, Lesson 3. So Lesson 2-3. In today's lesson, we are going to determine the domain of a function when applying operations to functions. Our language objective is to explain how to find the domain of a function when we need to do an operation. So let's take a look at today's do now. Let's take a look at today's do now. In today's do now, we have been given a graph, a function, and we want to state the domain and range using interval notation, set notation, and inequality notation. So this is taking us back to the first lesson we went through. I am going to make you guys pause this video, try these problems out, these notations out, and let's see if we have the same exact answer. All right, so here we have our domain. Our domain is from negative infinity to -6, including -6. And then there's a big jump here from +3, including 3, all the way to infinity. The range starts off at 0, including 0, and does go all the way to infinity. So there are my 3 types of notations represented using the domain and range. Now that we have those basics, we can actually apply them to more algebraic component to it. So our thinking for today is, how do we find the domain of a function containing operations? So in Unit 1, we did operations with functions, and this is what we're going to end up doing in this lesson, but also dealing with the domain. So number 1, evaluating function. You will need to evaluate a function first before finding the domain of the function. How do you know you need to evaluate a function? So if we have been given an input, that means that we have to do some sort of evaluating. 2, operations on functions. So you will need to perform operations first before finding the domain of the function. Again, how do we know we need to perform operations on functions? So if we have been given both an input and also operations, right, one of the 4 operations, then we have to do this process first. Operations on functions, then we can find the domain. 3, you will need to find the domain of the function's output by determining which case to use. So how do we find the domain using its cases? Remember, there's 5 cases. Okay, so we have 5 different cases: polynomial only, fraction only, square root only, but we could have the combo of a fraction with the square root either in the denominator or in the numerator. And we do need to remember the 5 cases so we know how to set up our domain. So let's try these. For our first problem, we want to find the domain using interval notation, and they have given us f of 3x. I see an input. So what I have to do first is input this 3x into the f function, and we're going to see what the output is. So my f function is 2x squared minus 3. Instead of an x, I'm inputting 3x. I'm going to evaluate this and simplify as much as possible. All right, so here is my output. I input that 3x. My output turned out to be 18x squared minus 3. At this point, what I am going to identify, what case do I have? I have a polynomial. Since I have a polynomial, that means that the domain, using interval notation, goes from negative infinity to positive infinity. So the extra step here is me having to do my input piece. Let's look at number 2. Find the domain using set notation this time, and we have been given g of a plus 2. This a plus 2 is our input. So what we are going to do is we're going to input this a plus 2 into the g function, simplify, and see what we get. Okay, so I end up getting the square root of negative 3a minus 2 as my output. Since I have that output, I'm going to ask myself, what case do I have now? I have a square root only case. So with the square root only, I am going to set up my radicand greater than or equal to 0, and that's going to be my domain. So I end up at a is less than or equal to negative 2/3. Make sure you remember your rules of inequalities. When you divide by a negative number, that inequality switches. So you must remember to switch. Now that I have that inequality, I can represent this answer using set notation. So my domain is, so I have a such that a is less than or equal to negative 2/3. All right, last two types of problems. We have find the domain using set notation, and we have been given f divided by g, where my input is 2n minus 3. So what we are going to do is we're going to do the operations with that given input, simplify as much as possible, and see what we end up. All right, so after simplifying everything, I end up at a fraction with the square root situation. The square root is at the bottom, so what I am going to start doing is setting the radicand greater than 0. My domain is n is less than 13/6. This represented in set notation as being asked would be n such that n is less than 13/6. Number 4, we have similar situation. We have a g function divided by 3 times an h function where our input is 4p minus 5. So I'm going to do the same process. I'm going to simplify as much as possible, get to an output piece, and see what I have. After simplifying, combining like terms, distributing, and doing everything, I end up at an output that we have a square root at the top for my numerator, and I have a fraction. So in this case, this is a combo case. I am going to start off with my denominator, not equal to 0. So my denominator cannot equal 7/6. For my radical piece, since it's in the numerator, that means that the radical can be greater than or equal to 0. So my radical piece can be less than or equal to 19/12. Again, I am not showing all my steps, but I am dividing by a negative number and I have an inequality. You must remember to switch that inequality. Now that I have the two pieces, I'm going to put them together and I am going to see where they intersect. So there is my setup. I have 7/6 roughly 1.2 and 19/12 roughly 1.6. So I put them on my number line, getting myself ready, starting to fill it in. So the first piece is that P cannot equal 7/6, but it can be every single thing else. And the radical piece said P has to be less than or equal to 19/12. So we have 19/12. including, and all of these numbers that are less than. So what is part of my inequality? The piece that's part of my inequality is all of this. This piece on the right is garbage, pretty much out of the domain. We don't include that in the domain. And now I could actually write the domain of the function. The domain goes from negative infinity to 7 over 6, not including, union 7 over 6 to 19 over 12, including. When you are given these types of problems, you must first find the output given the input. You must do the operations first, and then you can find the domain of the function. So keep learning, keep growing, and I will see you in our next video.